Well, what is up? It's Mr. Uy here, coming to you live and direct to give you your unit test study guide on circles and 3D figures. Let's take a look at what you need to understand for this upcoming test. The expectations for this video are obviously to take some good notes because you're going to hopefully make a good resource that you can utilize on the exam. You will be turning this in after the exam, so you might as well make sure that you're also creating a good resource that you can use on the exam while also completing an assignment in class as well. So let's take a look at our first topic that's going to be on the exam, and let's get good at the types of problems that you might see as well. All right, so with your notes in front of you, here is the first topic that we're going to go over for the exam. Zooming in on the parts of the circle, these are the parts that you guys need to familiarize yourself with. Obviously, what we need first is what is called the radius. Starting from the center of the circle to one of the edges, a radius measures half the distance from end to end in the circle passing through the center. The other thing that we're going to need for a circle is the distance that goes all the way across both sides. That's called the diameter, and we use that lowercase d to denote the diameter. So this is the picture that I want you to draw, and don't forget that r represents radius and d represents diameter. That's the first thing in our notes that you guys need to get good with. Now that you have the parts of the circle down, let's take a look at the area problems that we're going to need. Now, the first thing that I want you to write down is the area formula for a circle. Next to where it says area, the area formula is capital A is equal to pi times radius squared. Now, don't forget we use 3.14 for pi, and r just represents radius. So in our first example, let's take a look at how we were to solve this if we encountered it on the test. The first thing that you need to draw that you'll be given on these problems is the radius. I'm going to say that this radius is 4 feet. Now, in order to find the area of the circle, I just need to use that formula that I have right up above. Area is equal to pi times radius squared. In this case, our radius is 4. So wherever I see an r, I'm going to plug in that 4. So now my formula reads pi times 4 squared. Now, to rewrite this as a multiplication problem for my calculator, all I need to do is replace these things with the multiplication that it represents. Pi, I'm going to use 3.14. I'm going to multiply that times 4 squared. And we know that when we square something, we're just going to multiply it by itself 2 times. So that's 4 times 4. So in my calculator, what I'm now going to plug in is 3.14 times 4 times 4. And that gives me a grand total of 50.24. In this case, let's round to 1 decimal place, and we're going to get 50.2 feet squared. Now, don't forget that the units matter a lot. When we deal with area, we always square our units. This is how we do our first major problem for area. Now let's take a look at a different type of problem for area, scrolling down to our second circle. Now, what if I gave you a different distance? Instead of giving you the radius, I could give you something that is similar to the radius, but maybe not as useful. Instead, I'm going to give you the distance all the way across the circle, and I'm going to say that this is 10 centimeters. Now, if I were to ask you to find the area, you still do the same thing as we did up above. The only difference is making sure that you're careful with the number that you're plugging in for radius. Since the diameter of this circle is 10, I know that a radius would actually be half of that, which would be 5 centimeters. So now using my formula, area is equal to pi times radius squared. All I'm going to do now is plug in what I know. I know that my radius is 5, aka half that 10, and now I have my expression pi times 5 squared. Now, using the same reasoning as up above, let's replace these things with the multiplication problem that I know I'm going to plug into my calculator. 3.14 is pi times 5, which is what 5 squared is. In my calculator, I'm going to type in 3.14 times 5, and that gives me a grand total of 78.5 centimeters squared. Now, this is how you tackle any type of area problem that you might encounter for circles. You just got to be careful with regards to your multiplication and with regards to what you're plugging in. So these are our first 2 examples for area. Make sure you write them down, and let's move on to circumference. All right, now that we've got area down for circles, the last thing that we're going to need for circles is called the circumference. Now for the circumference, the formula is a little bit different. Capital C stands for circumference, and it's pi times diameter, or 2 times pi times radius. Now, either of these formulas work to find the circumference. It's just a matter of what you're given in the pictures to be able to use whichever one you think is the most appropriate. So first example, if I gave you that the diameter of this circle all the way across is 20 feet, how would I find the circumference? So using the first formula, circumference is equal to pi times diameter. All I need to do is plug in 20 for my diameter. So this turns into pi times 20. The multiplication problem that I'm going to feed my calculator is 3.14 for pi times 20, which is that diameter that I see in the circle. So on my calculator, I'm going to type in 3.14 times 20, and I get a grand total of 62.8. Now in this case, since we're not dealing with area, we're only dealing with circumference here, our units are just feet. So this is how we use what we know to find the circumference. Now the only other type of way that this question can be asked is if instead they give you a radius. So instead I'm going to give you that this radius here is 15 meters. Now to find the circumference for this, I can't use the diameter formula. I'm going to use the 2 times pi times r formula. So in this case, circumference is 2 times pi times radius. And since I have the radius and not the diameter, I'm going to plug it into my formula now. So this turns into 2 times pi times 15. And in my calculator, I'm going to plug in 2 times 3.14, which is pi, times 15. And in this case, I get the answer of, so 2 times 3.14 times 15 gives me 94.2 meters. So again, we don't square our units in this case because we're dealing with circumference. Now that we're done with circles, make sure that you take a moment and you understand the requirements for both of these types of ideas. So now let's take a look at the next topic on the test, and that's surface area. All right, now that we're done with circles, let's take a look at surface area. Now the surface area section of this exam is really straightforward because all you need is the definition and what the nets look like. For the definition, surface area is defined as the total 2D flat surfaces that create the object. Something that we covered earlier in our research are these things called nets. Now make sure that you understand what these nets represent. For a cube, the net is the unfolded boxes that net creates. So in this case, if you imagine unfolding that cube, it turns into a net that looks like that. The cuboid, aka a rectangular prism, unfolded looks like this. So again, if your picture is a little blurry or you don't see the lines, just make sure that you trace them out so that you understand what they look like. The square-based pyramid, similarly unfolded, looks like the following. The cylinder looks like that, and the cone at the very bottom looks like that unfolded. Now, the only thing that you might see on the exam that's not listed here is the net of a sphere. Now, a good way to think about the net of the sphere is if you were to unfold a basketball, what type of thing would you get? And you've seen that when you did your research, that the sphere is made up of these little sections, these little, so not cylinders, but these little pointed sections that are unfolded like an accordion for a sphere. So take a moment, make sure that you write that down in your notes because those are all the things that you would need to figure out for surface area. So there's no calculations for surface area. There really is just your conceptual understanding and then being able to identify a net, which is the unfolded two-dimensional shape that's created from a 3D shape. So now this is where we can move on to the last and final part of the test, and that's volume. So let's take a look. All right, now that we've got circles and surface area down, let's take a look at volume. Volume is defined as the amount of 3D space an object inhabits. Basically, it's the amount of inside stuff that we can measure in a three-dimensional object. Now, how we find volume is in three specific steps. We make sure that we label the dimensions that we are given. Then we plug it in, that info into a formula that we need. And then all we have to do is evaluate and simplify using a calculator. So for example, my rectangular prism down below has a length, a width, and a height. The volume formula, which is capital V, is found by just multiplying these three things: length times width times height. So for an example, if I gave you that the length was 2 feet, the width was 1 foot, and the height was 3 feet, let's take a moment and find out how we find the volume. Now, to find the volume, all we have to do is use the formula we wrote down, which is length times width times height, and plug in the appropriate numbers. 2 is my length, times 1, which is my width, times 3, which is my height. Using a calculator if I need it, 2 times 1 times 3 gives me a grand total of 6. Now, this is where you need to make sure that your units are on lock. When we calculate three-dimensional area, aka volume, our units aren't squared, they are cubed. So in this case, my volume is 6 feet cubed because it is a three-dimensional area. So this is an example of how we find volume for a rectangular prism. Let's take a look at 4 more examples with different formulas for how you find volume of different 3D shapes. Let's keep on going. All right, now that we've got the volume formula for a rectangular prism down, let's take a look at the volume formula for a square pyramid. Now, the dimensions that we use for a square pyramid are very similar to the rectangular prism. We've got the length down here, the width going across the bottom, and the height of this particular piece is how tall the pyramid is. That's called the height. Now, one of the things that we can do now is find the formula. The formula for the volume of a rectangular or square pyramid here is length times width times height divided by 3. Now, if you're thinking to yourself, this looks familiar, it should, because it's literally the same exact formula as a square or a rectangular prism. The only difference is that it is a pyramid. Now, for our example, let's attach some numbers here. If the length of my square base pyramid was 4 meters, the width was something different, maybe 3 meters, and my height was something like 5 meters, let's use the formula and see what we get. So using the formula and our 3 numbers, when we plug it in, the length is 4 times the width, which is 3, times the height, which is 5, all divided by 3. Now, at this point, I can use my calculator and I can see what I get here. So 4 times 3 times 5 on the top gives me a grand total of 60. Last step here on my calculator is dividing 60 by 3. So 60 over 3, aka 60 divided by 3, gives me a grand total of 20. Now don't forget the units. It is meters, but those meters are cubed because we're dealing with three-dimensional area. So this is how we find the volume of a pyramid. Any other problem is done the exact same way. The only difference is the numbers that you would be plugging in when you do your multiplication and division on the calculator. So now let's take a look at our next shape, which is the cylinder. All right, our next shape is the cylinder. For the cylinder, these are the 2 dimensions that you are going to need. The first one is the radius of the top or the bottom circle. Just like the same radius that we learned at the very beginning of these notes, that radius is just halfway distance between the middle of the circle and to the end. The other dimension that we need to find the volume is the height of the cylinder. And that's just how tall the cylinder is when it's sitting on one of those flat circle bases. Now, the volume formula for a cylinder is the following. It's pi times r squared times height. Now, if part of this formula looks familiar, it should, because the first part is just the area formula of a circle. The height is just how tall that particular cylinder is. So for an example, let's attach some numbers here. If I told you that the radius was 3 centimeters and the height was 5 centimeters, let's take a look at what our numbers would look like when we plug them into our formula. So now that we know that the radius is 3 and the height is 5, the volume formula now turns into pi times 3 squared times 5. All I did was I plugged in the numbers into the letters that they are attached to. Now I'm going to rewrite this so that I can plug it into my calculator. 3.14 is what I replace pi with. 3 squared is just 3 times 3. And 5 at the end is being multiplied, aka the height. So now in my calculator, I'm going to multiply this all out. 3.14 times 3 times 3 times 5 gives me a grand total of 141.3. Now don't forget the units. In this case, I'm dealing with centimeters, and those centimeters are cubed because I'm dealing with three-dimensional space. Now I'm done with my problem, and now I'm done with finding the volume of a cylinder. Next one is the cone. Let's see how these things are connected. Now, second to last three-dimensional shape you're going to need to find the volume of is the cone. The cone has two dimensions that we need. One of them, very similar to the cylinder and the circle, is that radius at the bottom. So again, that's the distance from the middle all the way to the end of that bottom part of the circle. The second dimension that we need here is the height. That's how tall the cone is when it's sitting on the flat portion of the cone. Now, our volume formula is going to look very similar to the volume formula of the cylinder. Let's see if you can make a connection here. So it's pi times radius squared times the height all over 3. Now, just like the volume of a pyramid is 1/3, aka a third of the prism, the rectangular prism, the volume formula for a cone is the exact same thing as a cylinder. It's just a third of its size, aka dividing by that 3. Now, using some example numbers here, if I gave you that the radius down here was 4 meters and that the height up here was 5 meters, let's take a look at how we could use this formula to find the volume. Now, in this case, my volume formula is very similar to the cylinder in the sense that all I need is to plug in the radius and the height. So my pi times the radius, which I said was 4, squared times the height, which is 5, all over 3. Now, this is where I need to be really careful with my order of operations. So the first thing that I'm going to do is carry out the multiplication on the numerator of this fraction. So in this case, that's 3.14 times 4, which is 4 squared, times 5, all over 3. Once I do this in my calculator, I'm going to multiply it out. 3.14 times 4 times 4 times 5 gives me 251.2. So I'm going to write that down. 251.2 all over 3. Now, I'm not done yet because I've got one last and final step here. My last and final step is to divide this number by 3. Now I get this crazy looking number. So let me zoom in here so I have it right. I've got 83.7. So always round to one decimal place. I'm going to round that 83.7. So I'm going to put my about symbol, 83.7. And the units that I'm dealing with here are meters, and those are cubed meters because we're dealing in three-dimensional space. So each and every single one of these steps are important. It's very easy to make a mistake. So just make sure that you write down these steps in your notes as clearly as possible and make sure that you understand each step so that you don't make a silly mistake on the exam. Now let's take a look at our final 3D shape, and that's our friend, the sphere. All right, so this last piece of information is for our three-dimensional sphere. Now, the only dimension you need for a sphere is the radius. So imagine going to the center of that sphere and taking the distance all the way to one of the edges. That's called the radius. The volume formula for our sphere here is a weird one. So please write it down carefully. So it's 4 over 3. And on the numerator, check out what I'm going to write down. It's 4 times pi times r cubed. So this formula has definitely a lot different things in it. Although it still has it divided by 3, That pi r cubed is definitely something that's a bit different. So let's take a look at an example in which you're given a number. If I told you that the radius was, I don't know, let's go 8. Let's say that it's 8 feet all the way across for the radius. Let's take a look at what we would plug in for our formula. So our formula is V is equal to 4 times pi times radius, in this case is 8 cubed. Now in this case, this is where you need to be very careful for how you write down the multiplication in the numerator here. So 4 is still just 4 times pi, which is 3.14, times 8 cubed. Now don't forget, when we cube a number, we're multiplying it by itself 3 times. So that's 8 times 8 times 8. And again, don't forget that it's still all over 3. Now I'm just going to multiply the top part. 4 times 3.14 times 8 times 8 times 8 gives me a grand total of 6,430.72. Now don't forget it's still over 3 because that's our last step. Our last step is to divide this number by 3, and I get my grand total of about 43.6, again rounding to one decimal place, feet cubed. And again, don't forget to cube those units when we're dealing with a three-dimensional volume here, because we're counting in 3 dimensions. All right, so now that we're done with the sphere, this is all the 3D figures that you need to be able to understand and use the formula for. It's really nothing more than plugging it in and using a calculator as carefully as you can. All right, that's it. If you took the notes, just make sure that you keep these safe because you can use it on the exam. Make sure you turn it in for points after the exam as well, because it's definitely something that can help you study tonight and definitely something that can help you on the final exam of the year. So hopefully you guys are definitely ready to study. Use this wisely and make sure that you do the practice test as well. Thanks for listening, and I'll see you later. Peace.